Right, welcome back. This is another video. Again, we're looking at the second question here of this revision material. Take note here, we have to calculate and check by applying the distributive property. Now, what does the distributive property says? Remember, this is what it says. If I have a number and I have in brackets two other numbers that are different, I can actually find the answer in a simple manner by multiplying the number outside the bracket by the first number inside the bracket, keep the sign, and multiply the number outside the bracket by the other number inside the bracket. Okay, so this is what the distributive property says. Now, I want to show you how it makes our life easy when it comes to sums like this. Remember here, you are not really allowed to use the calculator. So you kind of need to show all steps that you would have gone through to obtain your final answer. So let me do 2.1 here. We have 7 times 23 plus 14. Now, I am very much sure you know what 14 is, okay? I mean 14 plus 23. Yeah, that's what I meant. So if you add 23 and a 14, you would do your column addition, I think, something like this from primary school, and that gives you a 7, and that gives you a 3. So we know it's 37. But it's probably still quite hard to multiply 37 by 7, right? So you want to break down 37 as a sum of 30 and the number 7. Now, this is where the distributive property comes in. I'm going to multiply this 7 by the 30, and I'm going to multiply it by the 7 again. We should know multiples of 10, how they work out with any number. So when you multiply 7 by 30, you can just ignore the 0. You just put it there. It's a placeholder, basically. So 7 times 3, for example, is 21. So you're just going to say 210. Then we must know multiples. So 7 times 7 is 49. Now, it is definitely easy for you to add this, is it not? 9, 5, 2. So you know now the answer is 259. So this is how the distributive property comes into this whole picture to help you verify what is going on here. Now, guess what? The distributive property can also be applied for division. And I want you to see what I mean by that. It's slightly different. I know I'm probably confusing you now when I say it can be applied for division, but watch what's going to happen here. Remember, brackets first, and then everything follows after. So if I add 81 and 54, which I'm very much sure you can do, I want to write this going downwards. So that would give us a 135. So that's 135. And this has to be divided by what? 5. Again, this looks like a what? Some form of pretty complicated division. So we're going to make our life very simple. Watch how simple. I'm going to break down 135 into 100 and a 35 like that. And remember, this is divided by 5. Now, I need you to think backwards here. If I have two fractions, let's say, for argument's sake, I have 3 over 2 plus 5 over 2. What's going to happen here? Well, because denominators are the same, I'm just going to keep the denominator and add the 2, right? That's what we have learned. Now, we're going to reverse this process. I want you to think with this. What we have here in this situation is actually what we have here. Now we want to move backwards like that. So in other words, that's what I'm saying. We want to have this as 100 over 5, and we have 35 over 5. We are kind of distributing the denominator to the two numerators there. That's what we're kind of doing. Or if you like, you may call it a split. Now, everyone must know what 100 divided by 5 is. 2, 4, 6, 8, 10, right? So that must be a 20. And you must know multiples of what? Of 5. So everyone must know it. Like if you count in 5s, how many times do you have to count in 5s to get to 35? of course, that is 7 times. So that means the answer to this whole thing is actually a what? A 27. And I can guarantee you, you can try your nice, smart Casio FX82 calculators and see if it will return this answer. But this is the main thing that I needed you to understand. I don't just like giving answers. I want you to actually understand why we get such answers. All right, let us move on and try this ratio problem. It is one of the common ones. Again, divide 360 between Tandy and Mary in the ratio 4:5. So what is happening here? That means Tandy is sharing the money with Mary, and we can assume this is how they're sharing the money. Now, to know how much each one is going to get, first of all, we need to find out actually what is 4 plus what? Plus 5, okay? That is a 9, right? So that means, how did we get here? Well, we got here because Tandy was getting 4 out of 9 portions, while Mary was getting 5 out of 9. Now, we just need to find out what or how much is 4 out of 9 parts as far as 360 is concerned. So for this one, I will really allow you to go into the calculator and press 4 over 9 times 360. You just punch it the way it is. You should get something like 160 if you're doing this correctly. And similarly, if you do 360 by 5 over 9, that should give you a 200. Take note, very important. If you add these two numbers, guess what? You get 360, the original amount. Not only that, if you were to simplify the ratio of these two numbers, 160 to 200, obviously the units will cancel out. What is the highest common factor between 160 and 200? It is 40. But let's say you did not know. Let's say you did not know and you just guess, and you guess 2, because I'm sure that is the most likely number you're going to try. Then you're going to get 80. And then this side, you're going to get what? 100. But you can still see there's a number that goes into both. And this time it becomes clear it is 20, right? So you divide 80 by 20, you're going to get 4. But then when you divide 100 by 20, you're going to get 5. So this thing takes you back right there. This is just something to confirm to you whether you have been doing the right thing or not. All right, I hope you have enjoyed this. I try and keep this video short so that you understand this briefly and there's no information overload. You can tune in and keep watching the rest of the videos in the playlist.